internally and try to understand some preserving concepts with respect to the hidden layers what we had. And it is also generated with corresponding three different layers or three different output results. So it may be asked something called as, sorry I'm not helpful, sorry I am not helpful. So like this, sorry I'm not helpful. So like this is going to be some text results, right? Or you can say voice kind of the results, maybe from your phone. So whenever you ask some word with respect to your phone or anything such that, so we try to preserve one to many relationship with respect to the neural network what we had, and something called as a one to many to one also. So whenever you type any kind of you can say some such as root words with respect to the nodes. Suppose you search it with the pin codes, collection of the pin codes, which city it belongs to, which city is going to be belongs to. So I have searched with 5 pin codes and it will give only the one city name. Or you can also search number of the lakes in such city, or number of the such visiting places as university. So like that, this is some of the NLP related applications. Whenever you search it, it's grouped together and giving only the one results at a time. And many to one, we have so many applications. I can say one is called as a Google Translator. Google Translator, whenever you give some of the information like hi, you can say hi in terms of the English, you want to convert into Urdu, you want to convert into Urdu or Hindi maybe. So it will give with respect to whatever the information you given from this node or this node or this node. It's try to preserve with this node and this node, this node. So like that you will get 3 to 3 kind of the output results. Similarly, many to many and also the many to one. So you can play around with this. This is very useful whenever you have to know about some of the applications to understand. So let's go and check out the MLP related with our iris data set what we had. Just play around with it, then we can wrap up. Maybe we can see in the next videos for the RNN concept. So from the scikit-learn, we are going to be get all these things. You can see here neural networks, and we already seen the pre-processing standard scalar and also the minimax scalar. MLP related concepts came into the picture from the scikit-learn also, and something called as a tensor flow. So we have seen something called as a tensor, right? At the time we learned some classical ML stuff. So tensor flow is going to be very helpful whenever you have 3D to 4D or 4D to 5D and also the 600D you can say. So it will preserve all the information with corresponding to any dimension, any dimension. So let's take the cube. So you are going to be showcase only the 3D, right? Until you're going to be satisfied with corresponding to the dimension. So you're going to be learn up to 3D, but you cannot preserve the 4D in terms of the visualization of the humankind. So whenever you try to understand 10D or 100D, you can use the TensorFlow. That is a basic advantage from the TensorFlow. You're going to be learn so many things. You are going to be have so many hidden layers such as LSTMs, RNN, and GRUs, along with some of the activation functions, and also the optimizers, and weight initialization. We just now spoke about that, and obviously MLP concepts, backpropagation algorithm. So many different concepts we are going to be get it from the TensorFlow itself. And one of the good advantages with the TensorFlow is it is the inbuilt functions of the Keras. So Keras is a much popular and easy to understand when compared to the TensorFlow. So if you understood the Keras, how does that going to be helpful when compared to the TensorFlow? So TensorFlow is slightly going to be somewhat different, and it's going to be hard to understand when compared to the Keras. So if you are a beginner, if you are a learner very faster when compared to the other models what we just know from the scikit-learn, so I will suggest to go through the first Keras. Keras is much better when compared to the TensorFlow. Then if you understood the Keras concepts, then you can go for the TensorFlow related to that. So it is always been, if you go and check out maybe TensorFlow.keras, TensorFlow.keras. So it is already inbuilt. Whatever the functionalities we had with respect to the Keras is already inbuilt. You can see tf.keras. So if you try to understand these concepts, whatever the TensorFlow they are providing with activation functions and also some of the callback results, you will also get some databases, optimizations, models, hidden layers, regularizations. So these are all inbuilt functions. If you go and see the Keras model also, Keras documentation, so it's already inbuilt with corresponding to the TensorFlow. This is very easy to understand when compared to that. So you can see it is already inbuilt with the TensorFlow 2.0. So nowadays 2.0 is also very popular, but you can learn from the first version itself. Then you can try to learn the second version also. So I'm suggesting go through these kind of the documentation. Try to you can also get so many APIs. You can see here so many APIs along with the learning kind of the references links. You can also install if you don't want. So for the collab notebook, you can install by using the you can say accelerator mark with the pip install TensorFlow. So like this, you can install. Some of the notebooks may not be preserved that much of information, but try to install whenever you need required, and also the version type, whatever the version 2 or 1 like that. So let's try to understand in the iris data set. We have the sepal length, sepal width, petal length, and petal width, and also the class width, which is a three different classes what we had, right, with respect to the flower. So let's take some standard stuff like label encoding and also some of the standardization techniques with respect to whatever the classes and data set we had. So what will happen if we just apply the multi-layer perceptron with the corresponding to the data set what we just learned? You can see we just imported the multi-layer classifier from our scikit-learn. We just passing some of the hidden layers. So this is the hidden layers passing for 10 hidden layers we are going to be showcased with corresponding to the 10 different input shapes what we had. So number of iterations we are just considering 1000 so that it will run some of the patterns according to the flowers what we had. So fitting with respect to the extend and also the white trend, so that we're going to be fit all the models together, so that it's going to be predict some of the values like this. You can say predict by using the X test. You can say it's going to be learned. This is the first flower. This is the first flower. This is the second flower. This is another flower, like zero flower. So if you go on to plot any confusion matrix, this is very easy to understand by whatever we done in the classical ML stuff. This is also very helpful. You can also use different matrix in the itself. So we already seen when to use, when not to use for the different evaluation matrix, right? So for the accuracy results, we can use for all the classification tasks without any imbalanced data sets. And if you have imbalanced data sets, you can come up with the law, you can come up with the EUC results and also the F1 score. And you are trying with some other multi-class classification with imbalanced data sets, you can use log laws. And if you are going with the regression task, you can use MSE values. If you are working with somehow the time series analysis, you can use R squared error. So R square score or MSE value, MAP values. So like this, we have constructed a way of analyzing data from the classical ML point of view. So these things will also matter in the deep learning. So whatever we learn in the classical ML, it's going to be works out in the deep learning concept. So whenever you learn some of the new concept in terms of the classical ML, obviously it's going to be works with the deep learning. But the little bit change only, I had to construct the number of the layers. So if you understood how to construct the number of the layers, these deep learning mechanisms are much easier when compared to whatever we learned in the classical ML. So I hope you understood. So let's walk on through these notes and also some of the PPTs I will also share with you so that you will get some idea how does that going to be helpful. So tomorrow we are going to be discussed with corresponding to the LSTM layer and also the GRU and what are the difference between the both the things, and we can also learn